So Unit 8 is all about polyhedrons, which are three-dimensional shapes. So that's what this whole unit is about, is three-dimensional shapes. A polyhedron is a 3D figure whose surfaces are polygons. Now, polygons are shapes that are connected with lines. So squares, triangles, whatever. Each polygon is called a face. An edge is the segment that is formed by the two faces, and the vertex is a point where the three edges meet. So imagine that you have this box of Kleenexes here, right? So this is a polyhedron, this cube is. So each face, like where you can kind of set it on the ground, is the face part. Then the lines that make up the sides are your edges, and then where three lines come together, you have your points. Okay, so you have your vertex, your edge, and your face. That's what the three pieces are. You have this formula. It looks like Euler, but it's pronounced Euler because it is of a different origin language. So Euler's formula says the number of faces plus the number of vertices equals the number of edges plus 2. So that's a formula that you need to memorize. A lot of times I just write F plus V equals E plus 2, and that works for any kind of shape that you have. So if you have this cube, you could count how many faces it has. So how many faces does a cube have? 6. So we would say 6 plus. Now, vertices are how many points that we have. So the top of the cube has 4, and the bottom of the cube also has. So together we have 8 equals the number of edges plus 2. So edges are your lines. So around the top there are 4 lines, and then around the middle part there are 4 lines, and then on the bottom there are 4 lines. So 4, 4, and 4 make 12 plus 2. Does that formula work? Well, 6 plus 8 is, which is the same as, there you go. So that works. So if you have a cube, it's not going to let me draw a cube. You can connect it together and you can see how many faces, vertices, and edges that you have. So if you're missing one or unsure of one of those, then you could just count up and make sure it matches in Euler's formula. I always draw a square and another square and then connect them. That's how I draw it. All right, we have these 5 types of regular polyhedrons. You do not have to draw the pictures, but do write down the 5 types of regular polyhedrons. The dodecahedron. Yes. You do need to memorize these 5 names that you have. Now, spell them close enough to what it should be. Mm-mm. Mm-hmm. Probably not. Probably. So to be a regular polyhedron, it means that all the angles are the same and all the side lengths are the same. So if you think about those definitions that we used last week, it's equilateral and equal angular. All the sides the same, all the angles the same. So a tetrahedron is that first shape there. It has 4 sides. What are all 4 sides? They're triangles, and they're specific kind of triangles. They are equilateral triangles because equilateral has all the sides equal. So 4 triangles coming together is a tetrahedron. So the next one is a hexahedron, also known as a cube. So if you say cube instead of hexahedron, I will count that. But the hexa part is telling us it's like a hexagon that has 6 sides, so hexahedron. Octahedron has 8 sides, and it's made up of 8 triangles again. Good, 8 equilateral triangles. Then we have our dodecahedron, which is like our soccer ball because it's 12 pentagons together. And the last one is an icosahedron, which is 20 equilateral triangles. Do y'all have y'all ever seen the Moravian stars before? You know, at Christmas time, you see them a lot hanging out. So the middle of the Moravian star is an icosahedron. So in order for somebody to make one, they have to make this base part, the icosahedron, and then they make triangles that attach to it. They actually make some tetrahedrons, or actually ones that are a little bit longer, and they connect it to make the Moravian star. I remember back in the 6th grade, we had to pick one of these and like make it by hand. And of course, I chose the icosahedron because I was stupid. But it was kind of difficult to make by hand, trying to cut it out and glue it together and make it into a ball. But you can definitely do that. There are kits online too that help you make those. If you wanted to do it yourself, you can actually print off a sheet and you cut it out and fold it and glue it together. And there you make an icosahedron. So what we're going to do next is we're going to use Euler's formula to help us find different things. So what does Euler's formula say? Good. Faces plus vertices equals edges plus 2. So let's look at some sample problems of that. Maybe. There we go. Now, don't worry about drawing the shapes. Mm-hmm. That'd be a good idea. Mm-hmm. Mm-hmm. It's all right. All right, so in our first example here, we do not have the faces, but we have the edges and vertices. So just set up your equation. Faces plus vertices equals edges plus 2. So F plus 9 equals 15 plus 2. And then just simplify and solve for F. So F plus 9 would equal 17. And then F would equal 8. And that's how you solve for that piece. All right, let's do number 2. So we would say 8 plus 12 equals E plus 2. So 8 plus 12 is 20, which equals E plus 2. So E would be 18. So pretty simple when it gives it in that form where it tells you what it leads to them are, you can find the other one. But sometimes you see a problem like this where it describes the shape and wants you to find the number of edges or vertices or faces. So this one says a polyhedron with 8 triangular faces. How could we put that together? What would that look like? An octahedron. So sometimes you have to think about what that shape would look like. Now, when you take a test or quiz, I may give you a kind of simpler shape to kind of put together. So if you're not sure when you're working on homework, just Google it. Type in polyhedron with 8 triangular faces and an image will pop up for you. But we're really looking at an icosahedron. Now, the edges are the lines, right? So how many lines are in this octahedron? Octahedron. You're exactly right. Yep, because up here at the top there are 4 triangles that come together, right? And at the bottom there are 4 triangles. So to make them come together, there's 4 lines on the top and bottom. And then to connect them, you have 4 lines. So there are 12 edges. If you wanted to set up an equation for it, you could still do your faces plus vertices equals edges plus 2. We know that there are 8 faces because it tells us that. Then we just need to find out how many vertices there would be, how many times they connect. So if we go back to the picture, there's 1 here at the top, 1 here at the bottom, and then there would be 4 in the middle where you put those together. So there are 6. So 14 equals E plus 2. So E must be 12. So if you can visualize it, that's good. If you cannot, you could Google it to kind of see what it looks like. All right? Not on the test, on homework. But on the test, I'll probably give you more like numbers 1 and 2. Because for me, it was hard for me to think about this too. All right, the rest of these I have printed for you, so you don't have to write this down, but you can print it. But keep that notebook paper out. You will still need it for what we do after this. But cross-section is what we are doing next. A cross-section is the intersection of a solid and a plane. Think about it as a very thin slice of the solid. When you describe a cross-section, you describe it as a 2-dimensional shape, okay? So imagine that we have this block. To me, it looks like a little stick of butter, right? That's what it looks like to me. So imagine that you cut it and then made a stamp of it. What would that stamp shape be? A square. Yep, you're exactly right. It would be a square. I gotta stop writing on the picture. So it would be a square. Now, what would it be for part B? A triangle. So when you answer these questions about cross-section, think about a 2D figure that it would make. And a lot of people like that idea of making a stamp. So you kind of cut it and then you go, and be like, what does that stamp look like? And that's what it would be. Okay? A lot of times if it's parallel to the base, it's the same shape as that base. So 2-dimensional figure. All right, right here it says draw a figure that has the same cross area. Now notice that this plane that's coming through is coming through at a diagonal. So which one do you think it would be if you cut it through like a diagonal, but then remember we stamp it on a piece of paper? C is correct. Good job. A lot of people like to say D, but imagine that you have to go through and lay it down and stamp it down. It's going to look flatter. It's not going to look this diagonally shaped. All right, this one is about a rotation. So imagine that you rotated this piece around. What shape would give us this 3-dimensional shape? C as well. That's right. Some people like to say A, but that would just do the top part because notice there's a pointy part down here at the bottom too. Any questions on these problems that we just did? Okay. I've got to open up my next document because I took them apart. So the next thing that we're going to talk about, you might want to write this down on your notebook paper, is looking at formulas for prisms and cylinders. And we're going to do some examples. So write down these equations and all this information here on the left on your notebook paper. And then on the back of the notes that I gave out to you, that's the examples that we will do. But write down this information on your notebook paper. You might need that space to write down the other stuff. Maybe if you can fit it at the top. Or, yeah, sure. Whatever you want to do. We're going to do all those examples, though. As long as it's spelled close enough, I will not count off for spelling. Basically, make sure it says hedron at the end and then close enough at the beginning. No. While you're writing this down, just to let you know, on the problems that you have tonight for homework and tomorrow, we're going to be finding 3 things for each shape that you have. We're going to find our lateral area, our surface area, and our volume. So today we're going to look at prisms and cylinders. Tomorrow we're going to look at pyramids and cones. And the formulas are very similar to each other. But on the EOC, they do not give you any formulas. None, 0, zip. So what are we going to have to do? Memorize them. There are a lot of formulas to memorize for this unit. Yeah, the EOC counts as 20% of your grade. Last 3 days class. We've been prepping all along. Yeah, but the last 3 days we focus on the EOC. Only 3, yep. We're lucky we get 3. I think 2 years ago I only had 2 days, so y'all get 3. Last year we had 3. There you go. There we go. Do that too. But I also want you to have them memorized by Monday, and I will remind you of which ones you need to know on Thursday by Monday, and we are going to take a little formula quiz. It won't really be a quiz. It actually will be part of your test grade on Monday. So memorize your formulas by Monday. But we'll take it towards like maybe the middle end of class, so that way you can practice them throughout the class on Monday, because Monday is also our review day. So lateral area, let's talk about what these mean. Lateral area is the sum of the area of the faces. So imagine we have our Kleenex box. It is around the outside, not the top or the bottom, but around the sides. I think about lateral area as painting a room. When you go like into your bedroom and you paint the walls, you paint around, right? Do you paint the floor or the ceiling? Typically we don't. So that's what lateral area is. It's around the outside, okay? Surface area is all the walls and the ceiling and the floor. So it's coming in here and throwing the paint on the walls, ceiling, and the floor that we have. That's surface area. Now, volume is filling it up. Imagine that you take a pitcher of water and you fill up the shape. How much do you have in there? So that's the difference between lateral area, surface area, and volume. Now, you can find them using your own ways and means that you want to, but these are formulas that will help you out. For prisms, prisms are polyhedrons with 2 congruent faces, and those are called bases. Like your cube, it's the top and the bottom. Okay, so in this rectangular prism, this part down here, come on, draw with me, this part and this part are your bases. Okay, and they're parallel to each other and they're the same shape. Okay, what are your bases in a triangular prism? It's the triangles that are on the end here and the end here. No, it's hard to draw triangular prisms, but the faces or bases will be the ones that are highlighted there. So in a triangular prism, they're the triangles because they have to be congruent, but they're also parallel from each other. Okay, so they're the parallel parts. So just because it's sitting on something doesn't mean that that's the base when you talk about a triangular prism. Now, the formulas are listed right here. The formula for lateral area is pH, where P is the perimeter of the base, and H would be the height. So the height is from base to base, okay? So on this one, this part would be our height, but on this one, this distance is our height from triangle to triangle. Surface area, notice it's the same thing because that's the area around the outside, plus twice B, where B is your area of the bases, because how many bases do prisms have? 2. Volume is area of the base times the height. Now, if you see a cube, more than likely you will say volume is length times width times height, right? Because length times width is the area of this base down here. So we've got to memorize these formulas, and now we're going to do these examples that are on your worksheet. So look at your worksheet that you have, turn to the back, and we're going to follow our formulas to find all 3 things here. Some things that I like to do first is I like to write down these things to the side. Let's go ahead and find P and B and H. So P is your perimeter of your base. Well, what numbers are on your base? Just 5 and 8, right? This is the part that it's sitting on, so this is the base. A lot of times I highlight it or make it a little darker. So imagine that we just have that shape with the numbers 5 and 8, and we find the perimeter of it. How do you find perimeter? Add up all the sides. Well, 5 plus 8 plus 5 plus 8. So what's 5, 5, 8, and 8? 26. The perimeter of that base is 26. If you need to write notes below it on how you got it, then go ahead and do that. So 5 plus 5, 8 plus 8. Now the other thing that we should go ahead and find is B. Capital B is the area of the base. So that base is a rectangle, right? How do you find area of a rectangle? Length times width. 5 times 8 is 40. The other letter that we need for our formula is H, which is the height. That's the height from base to base. What's that? 3. This part is our H, that number there to the side. So for lateral area, if we follow our formula, lateral area is pH. So P is 26. And H is 3. So what's 26 times 3? Grab those calculators out. 78? I think you're right. 78. Good. And because this is area, we need some units on it. This would be inches squared because it's talking about lateral area. Now, surface area, if you look at the formula, is pH plus 2B. Well, we already know what pH is. pH is 78. So why don't we just plug that into our formula? 78 plus 2 times B. Well, what's B? Bless you. 40. What is 2 times 40? 80. So this is really 78 plus 80, or 158. And don't forget units. This would be inches squared. Now, the last thing we need is volume. Volume is BH? Well, B is 40 and H is 3. So what's 40 times 3? 120. Now, this is volume, not area. Do you remember what the units are for volume? Inches cubed. That's right. Because it's like we're timesing 3 measurements together. The length times the width times the height, 5 times 8, then times 3. So you get 120. And that's all you got to do. Not too bad, huh? Let's try the next one. Just going to slide it over. Now, the next one is a triangular prism, but we still use the same formulas. Yes, Danielle? Exactly. Yes. Yeah. If you really wanted to go through and do that, you can. To me, this is probably a little bit easier, but you can do that. Now, what shape is the base on this one? It's the triangle, right? This is our base, which is the same as this one up here. It doesn't matter which one you highlight. So when I first go through and find P and B, I want to use that triangle there. I shouldn't write that there. Let me write it underneath so I'm more consistent. P and B. Now, I'm going to find the perimeter of that shape. Well, I have 8 and 15, but I'm missing this side right here, aren't I? Because I want to find the perimeter of this triangle. It's a right triangle, so what can we use in right triangles? Pythagorean theorem. 8 squared plus 15 squared equals what squared? If you're missing a part of it, look to see what shape that you have. It's probably a right triangle. So what's 8 squared? And 15 squared. Add those together. 289. 289 is actually a perfect square. What's the square root of 289? 17. That's how I know. That's actually one of those Pythagorean triples that works out. If the legs are 8 and 15, the hypotenuse has to be 17. So, do what? Well, because the first thing we have to find is P, which is the perimeter of that triangle. So, yeah, we need all 3 values to find the perimeter. So, let's add them all up. What's 8 plus 15 plus 17? 40. You're right. Now, we also need to find the area of that base. But what shape is that base? A triangle. What's the formula for area of a triangle? Good. 1/2 base times height. Now, in a triangle, imagine that you drew it to the side. You know that this part is 8, here's 15, and now here's our 17. If you have a right triangle, what parts are the base and the height? Yeah, the ones that touch the right angle. They're the legs. So that's what you use for area of the base. You're going to use your 8 and your 15. So let's type that in our calculator. So what is the area of that triangle or area of our base? It's 60. Good. Now the last thing we need for our formulas is the height. So the height is the distance from base to base, which would be 8. This is our height. Now we can plug them in the formulas to figure out our lateral area, surface area, and volume. So lateral area is PH. So P is 40 and H is 8. What is 40 times 8? Good, 320. And don't forget units on it. Meters squared. Good. Surface area is pH plus 2B. Well, pH we already know is 320. plus 2 times the area of the base, which we found to be 60. Just using that number that we already found. So what is 2 times 60? So 320 plus 120 is 440 meters squared. Now, the last thing we want to find is our volume. Volume equals BH. So B is 60 and H was 480 meters cubed. The more times you do this, the better off you will be with these formulas. That's why I'm trying to make sure that we do a lot of these, but it's just plugging them in. Sometimes the hardest part is finding the 3 parts of the base if it's a triangle and doing your Pythagorean theorem. Any questions so far? Okay, let's try one more of these and then we'll talk about some cylinders. So here we have another triangular prism. The bases are going to be the triangles. Now, what do you notice about that base? It's the same as the one that we just did. You will find that out a lot, that a lot of times you will get the same thing and you will see the same numbers. So do I need to do Pythagorean theorem again? Nope. I automatically know that this part is 17. So there are several problems where you'll see the same numbers, and if you have them memorized, you can just write them in, and that's fine. You don't have to show that work again. So what's the perimeter of this base? Well, it should be the same, so it is. And the area of this base. And then what's the height of this prism? 50. Yep. This part is going to be your H. So the distance from the triangle to the triangle will be your height. So let's just plug all those numbers in our formula. Lateral area is PH. So it would be 40 times 50. $2,000. And then don't forget feet squared. Yep, this one's in feet now, so be careful of the units. Surface area is PH plus 2B, so it's going to be our 2,000 plus 2 times 60, which was 120. So 2,000 plus 120 is... That's right. Don't forget your feet squared. Very good. And the last one is volume. BH. So 60 times 50. 3,000 feet cubed. Very good. So when you see a prism, make sure you pick out the triangles will always be the bases, or if it's a cube, it's whatever it sits on. So whatever, imagine that it's sitting on will be your base. The distance from base to base, base to base, is your height. Okay, so make sure you pick that out. A lot of times I like to pick that out at the beginning. If you pick out your height, then you don't use that to find your area and perimeter. So area and perimeter is used there, and then height is here. Okay, so make sure you use the triangle or whatever it's sitting on for the base. All right, go back to your notebook paper and let's write down our formulas for cylinder. Cylinder is like a can. Can of corn, can of green beans, can of peaches. I had this one friend, and we were talking about things. She was actually my roommate in college. Bless her little heart. But it was just so funny, the conversations that we had in college. But we were sitting around, and we were talking about, we had a can of pears. And I said, I really like my pears cold. And she said, I like my pears in a can. Okay. Right? That's how I looked too. That's what I thought too. I mean, I was like, okay. I mean, yeah, cans are good. I guess I was just saying I liked them cold. But I guess she meant, she preferred hers in a can than a tree, I guess, or eating them like raw. I was like, you just, yeah. Because I always took my can of pears and put them in the fridge. So she was like, V means volume. Yes, it does. Yeah. They do. They taste completely different if you eat like a pear or eat like canned pears or whatever. Yeah. Or the ones in like the ones in little plastic cups. Well, I prefer mine cold regardless if they're in a can or from a tree. All right, here's your formulas for cylinders. Now, these are actually, you don't have to write this down, but I just want to show you. These are the exact same formulas for prism. And you may be wondering, how are they the exact same, Miss Cook? Well, the one for prism, LA was pH, right? Where P stood for the perimeter of the base. Well, if you look at a cylinder, the bases are what? Circles. So you take your finger around the jar, circumference equals, which is the same as perimeter. Perimeter and circumference are the same thing. So all the P's get replaced with 2 pi r, and all of the capital B's get replaced with pi r squared, because that's the area of a circle. So if you know the equations for prism, all you have to do is replace the P's with 2 pi r and place the B's with pi r squared. Because we take our finger around the jar, circumference equals, for area you multiply r squared times that number, pi. So see? Ta-da! I guess I'm more excited about that than y'all are. But anyway, back to our problems here. We're going to find these 3 things for these last 2 things that are on your paper. So it gives you all the information. This is why I really love cylinders, because it gives you everything that you need. The only things that we need in these formulas are R and H. So what is R in this problem? 3. It even says R equals 3. Now what is H? 6, because it's the distance from circle to circle. So just plug them in. LA is 2 pi 3 6. Now, I like to leave mine in terms of pi. So if you do this in your calculator, you might want to do the same thing. Don't touch the pi button. Just do 2 times 3 times 6. 36. And don't forget to put the pi with it. And then don't forget units. Now, if you want to multiply through with pi, please use the pi button on your calculator. So what I mean by that is you could just type it in like this. You get your 36. But if you want to type it in with the pi, then use the pi button here. That's above the caret key. So if you said 113, round to 2 decimal places, 113.10, then that would be fine too. I've written it down both ways, so I'm not going to be too picky. On the EOC, they leave it in terms of pi, but you can just multiply your answers through to see which one matches. All right, for surface area, it is 2 pi RH plus 2 pi r squared. Now, if you remember, the first part is the same. This 36 pi is the same as that part there. So that part can just be replaced, just like in our prisms. 36 pi plus 2 pi 3 squared. Now remember, follow your order of operations. So 3 squared is 9 times 2 is. So this is really 36 pi plus 18 pi, or 54 pi meters squared. Now our last part that we want to find is our volume, and that's pi r squared h. So pi, 3 squared, and 6. Again, order of operations first. 3 squared is, and 9 times 6 is 54 pi. But now this units are meters cubed. You will see a lot of times that your surface area and volume will be the same. And that is okay. You might also see that your surface area is more than your volume. And that is fine too. All right, last one that we're going to do. Remember, you need the two things, your R and your H. What is R? 5. Good. It gives us the diameter, but we already know to cut that in half. And our height would be 2. And then we just do our formulas. Lateral area is 2 pi RH. Just plug in those numbers. So 2 pi 5 2, or good, 20 pi, 20 R, 20 pi, looks like R. That's what I think too. Mine does too sometimes. Surface area, 2 pi RH plus 2 pi R squared. We already know the first part is 20 pi. So we just really need to do the 2 pi R squared. 5 squared is times 2. So we got a 20 pi and a 50 pi. 70 pi. This just makes me want to eat pie. So 5 squared is 25 times 2 is 50. 50 pi centimeters cubed. And boom. All right, your homework tonight is this worksheet. Just a reminder on your prisms. The prisms, look for the triangles as the bases, or look at the bottom if it's like a cube shape. Take one, pass it back. Now, there looks like to be a lot of problems on the back, but I'm telling you that they go really quick because you're just matching things up. A lot of the ones on the back are like matching or multiple choice. So it looks like a lot more problems than it should be. Pick what side you want to do first and hop to it. You guys got 40 minutes, so you should be able to at least finish most of it. No.